Hey guys, my name is Ritz and I'm going to be teaching you about UART. So UART stands for Universal Asynchronous Receiver Transmitter. So what does all this mean? Well, before I go, let me tell you about the other two communication protocols that I've mentioned in my previous videos, which are I2C and SPI. So I2C, as we mentioned, uses a clock and data line, only 2 lines, and can have up to 128 devices on a single bus. That is if you have 7-bit addressing, and if you have 10-bit addressing, you have 1024 devices that you can put on a single bus, which is quite impressive. Now SPI, it is a bit more faster than I2C, but is limited to amount of devices you can have on the SPI bus, and that depends on your slave select and how many pins your master has. Okay, so let's move back onto UART. The A in UART stands for asynchronous, which means it has no clock. So if it has no clock, how does it know which data is which? Well, in order for it to work, the receiver and transmitter need to be on the same baud rate or bit rate. If they are on the same baud rate, then it can know exactly where the bits are being clocked and what is being clocked in. So UART communications is peer-to-peer. So you can't have multiple devices on the same UART bus. This can be a bit of a disadvantage if you want to have multiple devices in your design. So looking at the communication settings, so say device 1 wants to transfer some data to device 2. It needs to have these settings set up in order to communicate. So first of all is the baud rate, as we mentioned before. So there's some predefined baud rates that you can use, which start at 1200 all the way up to 115,200 bits per second. So as you notice, SPI is significantly faster than UART. However, UART is a little bit more versatile. Okay, so if I want to transfer something from device 1 to device 2, first of all, what I need to do is to send a start bit. So I send a start bit and device 2 registers that start bit. Then I send in my data bits. And this appears from D0 to D7. So the most significant bit is over here and the least significant bit is over there. It's quite the opposite on SPI and I2C. Now we send 8 bits, but we can also send 7 bits instead of 8, depending on what we want to do. What is also nice about UART is that we can send a parity bit. Now a parity bit is a single bit error checking mechanism. So your parity bit can either be odd or even. So if you set it to odd, so say for example, we count 4 ones. So there's 1, 2, 3, 4. So there's 4 ones. That means it is an even number. And thus, if you set it to odd, it will be 0. If you set it to even, it will be 1. Now, if you have 5 ones, for example, you know that it's an odd number. If it's odd, then odd will say 1. And if it was even, it will be 0. It's quite simple. And it's a very simple method for error checking. And then finally, we send our stop bit. That can be denoted as T. And that basically puts our UART bus into idle mode. We can even have 2 stop bits, depending on how fast our transfer is and if we want to wait a little bit before we start our transactions again. This is how it looks. So our signals start off on the TX line, it puts our bus into idle, and then it goes down to 0. This signifies our start bit. Then we send bits 0 to 7, depending on how many bits we specified. If our data bytes were set to 7, then we wouldn't have this. And also this is using 1 stop bit and no parity, so we don't have a parity at the moment. And to go to our stop bit, basically put our device high. And that means our bus is idle. Now this can be either on the TX or the RX line of device 1. This is a bidirectional protocol and works the same in either direction. Okay, so I'm sure that most of you are very familiar with this code. So if we want to send something to the device, and as you know, UART is also known as serial comms, and we can send XC code to and from our device. Now XC code stands for American Standard Code for Informative Interchange. So if we open up our serial terminal over here, our terminal will print sensor as well as the sensor value, and we can specify to print out almost anything that we want. These are some of the functions that we can use for our UART bus. And it's very simple and very fun to debug using serial. If you want to check out this code, check out the link down below. And then moving on to the ASCII code. this is how these symbols are represented in ASCII code. So if I specify a 48 hex code, that means it's an H. If I look for the byte 74, that'll give me T, and so on and so forth. So you can print a whole sentence just using these codes, or the ASCII codes. If you want to go more fancy, you can use the extended ASCII characters. Okay, so that is it for this lecture. Thank you for watching. Please don't forget to like, subscribe, share, and comment. Tell me what you think about the UART bus. Do you think it's better than the SPI and I2C bus? Please let me know in the comments down below, and I'll see you in the next lecture. Thank you for watching.